Day 15 of 60, and today we're going somewhere most security engineers avoid, deep into Linux file permissions. Here's the scenario. An alert just fired. You SSH into a host and you have 5 minutes to answer one question: did an attacker stage persistence using file permissions? Not theory. A real triage clock. By the end of this video you'll have a find command that catches Setuid persistence tricks, and you'll know why ls-law is lying to you about who can actually read that file. Let's go. First, the model. The kernel evaluates permissions in 3 layers. Layer 1 is classic DAC, the read, write, execute bits for owner, group, and other. Layer 2 is the special bits, Setuid, segid, and the sticky bit. Setuid is the dangerous one. It makes a binary run as its owner, usually root, no matter who launched it. Layer 3 is POSIX ACLs, and this is where engineers get burned. ACLs grant access on top of the standard bits, and ls-law only hints at them with a tiny plus sign. Miss that plus, miss the backdoor. Let's audit. The command that matters, find /sdev /perm-4000 perm-2000 perm-0002 printf %p%m%u %ty-%tm-%td Break it down. Sdev keeps us on one file system so we don't crawl into /prop. Perm-4000 is the magic. That leading dash means, has at least these bits set. Without the dash, Perm-4000 matches files with exactly that mode and nothing else, which is almost never what you want. So -4000 is Setuid, -2000 is segid, -0002 is world writable. The printf emits clean CSV, path, octal mode, owner, modification date. Now make it forensic. During triage you don't care about every Setuid binary, you care about new ones. Add a reference file, find /sdev perm-4000 newer /bin/bash ls. Any Setuid binary newer than bash is suspicious, because system binaries were all installed at the same time. An attacker who copies bash to /tmp and sets the Setuid bit lights up instantly. Pipe through stat format equals %n%a%u%g%z, and you reconstruct a timeline, name, permissions, owner, group, and change time as an epoch you can sort against your breach window. Here's the part your CM misses. Run getfackle r/etc/sudoers.d. You might see a line like user, developer, r, a named user granted read access through an ACL. Standard ls-law shows root-only permissions and a quiet plus sign, but the ACL silently hands a developer account read access to your sudo policy. That's a privilege escalation map sitting in plain sight. The fix is a baseline: dump getfackle r for your sensitive directories, commit it to git, and diff on every deploy. ACL drift becomes a code review, not a 3 AM incident. Scale it across a fleet. You don't need a CSPM platform for the first pass. Loop over your hosts, for h in $cat hosts.txt, do ssh$h, find /etc/usr/opt, sdev, perm-0002, not, type l2/dev/null, sed /s$h straight face / done sort. Every world writable file across 50 boxes, tagged by hostname, sorted so identical paths cluster together. The not type L skip symlinks, which are world writable by design and just create noise. 2 minutes, whole fleet, 0 new tooling. Then harden. A 10-line post-deploy gate, find /etc, sdev, perm-0002, not, type L, exec chmod ow, a / strips worldwrite from everything under /etc. For unexpected Setuid bits, generate the remediation instead of auto-running it, emit chmod US path lines into a report and route them through change control. You want a human approving Setuid changes, because a few of those binaries are supposed to exist. The script proposes, the ticket disposes. Day 15 done. The takeaway: permissions are simple, but auditing them at scale is where attackers hide, and perm-4000 newer plus getfackle is how you find them first. Subscribe for day 16.